Hey, hello, you're welcome to my channel. Now in this video, we want to find the antiderivative of this function x to the fourth power divided by x squared minus 1. Good. But first, let's just look at the integrand. It is an improper fraction, right? That is, the power of x in the numerator is bigger than what we have in the denominator. So we have to resolve that to a mixed fraction. So let me just put down the function and then see how we can look at it. So that would mean you will have x to the fourth power, right, divided by x squared minus 1. So what I would like to do there to that numerator is addition by 0. Okay, I'm going to add and subtract some things, okay, rather than going into polynomial long division. That would simplify this thing a little bit for us so that we get an improper a mixed fraction at the end of it thereof. Okay, so let's do addition by 0, and that would be by adding and subtracting some things. Okay, now let's subtract x squared, add x squared again, and again I'm going to subtract 1, and I will also add 1. So what we've done there is the addition by 0. If you check, all the terms that we added and subtracted, they are equal and opposite in sign, so they will all get to 0. Okay, good. And now that we've written that, we can go ahead and split the fractions into 3 parts, right? So I'm going to take the first two together in the numerator. That means we're going to have x to the fourth power minus x squared, then divided by x squared minus 1, and then we add it with x to the second power minus 1 divided by x squared minus 1, and then lastly we just take 1 divided by x squared minus 1. Good. So we can simplify this fraction, and we're going to have, well, x to the fourth power minus x. We can factor out x squared in the numerator, and when we factor that out, we're going to have just x squared. All right? When we factor out x squared in the numerator, what will be remaining will cancel out with the denominator. Good. And then we add it with, again, x squared, this and that, they are the same, so the result of that fraction will just give us 1. And then this last fraction, okay, to integrate that, we still need to take the integral of this. So to integrate this last fraction, we need to resolve it to a partial fraction, right? So we can do that by cover-up method or just by the standard way. But I'm going to just write out the partial fractions of this. That will be 1 over 2, then x minus 1. And again, we're going to have minus 1 over 2, and then x plus 1. That is just what we get when we resolve this fraction, okay, to its partial fractions. All right, good. And then we have to now take the integral of each of these. So we say the integral of x squared, right, the x plus the integral of 1, the x, then plus the integral of 1 over 2 times x minus 1, right, the x, and lastly minus the integral of 1 over 2 times x plus 1. We put down the dx like that. Okay, good. When we take the integral of this function, we're just going to enter with x raised to the power 3, then we're going to take 1/3 of that, right? That is just by increasing the power by 1 and dividing by the new power. Okay, good. And then we integrate just 1 over the x variable, we get x. And this one, well, we can do a use of to the denominator, but when we integrate this function, we're just going to have the natural logarithm of the denominator, but I've pulled out the 1/2. So we're going to enter with the natural logarithm of x minus 1. And you put that in absolute value to extend the domain of that integrand, or of that antiderivative. Okay, good. And lastly, we're going to have 1 over 2, or 1/2, the natural logarithm of x plus 1. Good. And we are done integrating, so we can add an arbitrary constant, okay? And the whole of this is the antiderivative of that function we were given, right? So that is just by resolving it to mixed fraction, okay, and then taking the integral of each of those. All right, great. Okay, that's better. All right, thanks for watching. Please subscribe to my channel.